Have you ever thought that gravity might be more than just a mysterious force keeping us on the ground? Einstein's theory of general relativity explains that gravity is actually the result of space-time curvature, caused by the presence of mass and energy. This curvature dictates the paths that matter and energy follow. So even though light usually travels in a straight line, its path can be bent and magnified by gravity, a phenomenon we know as gravitational lensing. Massive objects like galaxies and galaxy clusters can bend the light of objects that are behind them, acting like a natural lens that magnifies and distorts the image of those distant objects. This fascinating feature of nature allows astronomers to observe regions that are incredibly far away, as if using a cosmic magnifying glass. Using this method, along with the power of the James Webb Space Telescope, scientists were able to observe 5 incredibly dense protoglobular clusters, which date back to the dawn of the universe, when it was still in its early stages. And surprisingly, what we found was that the early universe was far more intricate than we had imagined. The James Webb Space Telescope has managed to identify what could be some of the universe's first star clusters. During its observations, the powerful telescope detected 5 protoglobular clusters, dense groups of millions of stars held together by gravity within a galaxy known as the cosmic jewel arc. This galaxy, which formed roughly 460 million years after the Big Bang, is named for its resemblance to a thin crescent arc. This region is the most highly magnified area observed from the first 500 million years of the universe, offering astronomers an unprecedented opportunity to study how the earliest stars shaped galaxies during the cosmic dawn. Within the cosmic jewel arc, astronomers identified 5 globular clusters in the process of forming, each spanning about 3.75 light-years in diameter. These protoclusters may host some of the universe's very first stars and provide key insights into the Epoch of Reionization, challenging our current cosmic models. During that epoch, the universe was filled with neutral hydrogen, creating a cosmic fog that blocked our view of the early universe. Over time, this hydrogen became ionized, clearing the fog and marking the start of the cosmic dawn. However, the exact processes that caused this ionization of hydrogen remain a mystery. These globular clusters might be crucial to better understanding that transition in the history of the cosmos. The early universe is very different from what we expected, says Angela Adamo, an astronomer at Stockholm University. Galaxies are far more luminous, they form stars at a rapid pace, and they do so within massive, dense star clusters. We are reconstructing our understanding of how the first galaxies were formed. To investigate this region of the early cosmos further, the researchers plan to conduct a spectroscopic analysis with the Webb telescope. This will allow astronomers to determine the physical properties of these clusters, refine their age estimates, and understand how the stars in these clusters influenced their surrounding galaxies. Astronomers currently estimate that the universe is around 13.8 billion years old. According to our models, the Epoch of Reionization began roughly 375 million years after the Big Bang, and likely concluded around 1 billion years later, placing this galaxy at a time when reionization was still in progress. This suggests that finding objects older than those in the cosmic jewel arc is unlikely. But as they say about the Webb telescope, never say never. Recently, it surprised us again by identifying the oldest known galaxy, surpassing the cosmic jewel arc by more than 100 million years. In October 2023 and January 2024, an international team of astronomers used Webb's near-infrared spectrograph, known as NIRSPEC, to study galaxies as part of the telescope's advanced deep extragalactic exploration program. What they found left scientists astounded. The telescope detected the spectrum of a galaxy that set a new record, observed only 290 million years after the Big Bang, corresponding to a redshift of approximately 14. In cosmology, redshift is used as a measure of how far a galaxy is from us. The greater the redshift, the farther away the galaxy is due to the universe's expansion. The brightness of this new galaxy was surprisingly high for an object so far away. Furthermore, its proximity to another galaxy created an illusion that both were part of a larger singular object, which prompted the team to gather new imaging data using Webb's near-infrared camera. The results suggested that the hypothesis of a high red shift could be correct. In January 2024, NIRSPEC observed the galaxy, now named Jades GSZ, for nearly 10 hours. Upon initial processing of the spectrum, clear evidence emerged confirming the galaxy's redshift at 1432, along with another dimmer galaxy named Jades GSZ 141, which is also at a similar distance. This discovery broke the record for the most distant galaxy, previously held by Jades GSZ 13, which existed when the universe was about 13.4 billion years old. The newly discovered galaxies, Jades GSZ 14 and Jades GSZ 141, are approximately 13.5 billion years old. This shouldn't be possible. Finding galaxies this old challenges the very foundation of our models. And not only is this galaxy the oldest we've ever found, but it's also one of the brightest. In the images, the source spans more than 1,600 light years, proving that the light we observe is primarily from young stars and not from emissions near a growing supermassive black hole. This amount of starlight suggests that the galaxy has several 100 million times the mass of our Sun. It raises the question, how could nature have formed such a bright, massive, and extensive galaxy in less than 300 million years? These aren't my words. They come from NASA's scientists. The discovery also showed that the galaxy contains intense emissions of ionized gas, seen as bright lines from hydrogen and oxygen. Finding oxygen in such a young galaxy is unexpected, suggesting that several generations of extremely massive stars existed before we observed this galaxy. These findings indicate that Jades GSZ 14 is markedly different from the galaxy types predicted by theoretical models and simulations of the early universe. Among the hundreds of other galaxies observed during the High Redshift survey, scientists have yet to find anything similar. However, this discovery was made within a relatively small section of the sky, and who knows? Perhaps there are many more luminous galaxies, even older, waiting to be discovered across the vast universe. Scientists believe that galaxies form in regions where gravity pulls gas and dark matter into dense clusters known as halos. In the early universe, these halos quickly merged to form larger structures. Discovering these early galaxies is crucial because it gives us insights into how galaxies like our Milky Way developed and evolved over time. Jades GSZ 14 is now the archetype of this phenomenon, said the lead author of the discovery paper. He added, "It is astonishing that the universe could create a galaxy like this in just 300 million years. Moreover, according to NASA, we could have detected this galaxy even if it were 10 times dimmer, which implies we may find galaxies that existed even earlier in the universe's history. So what does this mean for our cosmic model? Let us know your thoughts in the comments, and if you liked this video, don't forget to give it a thumbs up and subscribe to the channel for more fascinating stories about the mysteries of the universe. See you next time.